For the first time in more than 7 decades, the U.S. has opened a rare earth mine.
Tonight, at the opening of the first rare earth mine in more than 7 decades.
It began in silence, rust-stained creeks forgotten in the hills, dismissed as scars from a dying coal empire.
It is the global capital for rare earth elements, metals that are crucial for all sorts of technology, especially renewable energy.
But beneath that orange sludge hid something worth more than gold. As China tightened its grip on the metals of the future, America's dirtiest rivers revealed their strategic secret. And halfway across the world, Beijing held a switch the West couldn't ignore. The leverage beneath circuits. Every smartphone hums with it. So does every electric vehicle motor, wind turbine, guided missile, and fighter jet. Tiny, unseen, and indispensable, rare earth elements are the skeleton keys of modern power, and one country controls nearly all of them. For years, China quietly built a rare earth empire. It didn't just dominate mining, it perfected the far more critical step, processing. By 2025, China handled nearly 90% of the world's rare earth refinement, producing the magnetic materials that allow everything from F-35s to MRS-1 machines to function. Western nations, lulled by cheap imports and offshored pollution, watched this monopoly grow without sounding alarms. Then the switch flipped. In April 2025, following United States tariffs, Beijing struck back, issuing sweeping export controls on 7 categories of rare earths, including those essential for green tech and defense. Automakers scrambled, wind turbine projects paused, defense contractors stared down component shortages. Even more severe was China's second move, banning the export of processing technology itself. It wasn't just a supply cut, it was an intellectual lockout. One policy decision in Beijing had stalled the gears of global industry. And just like that, the world realized rare earths weren't just commodities, they were weapons. America wasn't merely lagging, it was exposed. Where the rivers bled rust. In the hills of northern West Virginia, some creeks once ran the color of blood and flame. Locals called them dead zones, lifeless streams choked by rust, their rocks stained red, their smell metallic and bitter. Fish disappeared, pipes corroded. For decades, this was just the cost of a coal-powered past. The culprit was pyrite, fool's gold. When mining companies carved into the mountains and walked away, they left veins of it exposed. Rain and oxygen did the rest, triggering a chemical reaction that bled acid through the ground. This toxic runoff, known as acid mine drainage, leaked into rivers across Appalachia, pulling iron, aluminum, and something far more valuable along with it. For years, this bright orange water was treated like poison. Expensive water treatment plants were built just to clean it up. Millions were spent on containment, not recovery. But then someone asked the right question. What exactly is in this waste? When geologists and chemists tested the water using modern tools, the results stunned them. That orange flow wasn't just corroding infrastructure, it was quietly transporting thousands of tons of rare earth elements every year. The same metals being hoarded and weaponized across the Pacific were leaking out of American coal country, nearly half of the United States' annual demand, flushed downstream. We weren't just cleaning pollution, we were throwing away strategic metals. Gold in the sludge piles. What began as a cleanup effort soon became a discovery mission. At dozens of acid mine drainage treatment sites, engineers were using lime and chemicals to neutralize the acidity, converting the metal-rich water into harmless sludge. This thick orange mud was dried and carted off to landfills, considered toxic waste, useful for nothing. But a research team at West Virginia University decided to analyze it. What they found flipped the entire narrative. Buried inside that sludge were concentrations of rare earth elements richer than some commercial mines abroad. At certain sites, each ton of dried mud contained nearly 2 pounds of high-demand elements like dysprosium, neodymium, and terbium. That may not sound like much, until you realize that in the world of rare earth mining, that's a jackpot. At a single treatment facility, the researchers estimated the accumulated rare earths could be worth up to $1 million over time, and that was just one site. Across Pennsylvania, Ohio, West Virginia, and Kentucky, hundreds of similar sites were doing the same thing, cleaning water, creating sludge, and throwing it away. Then came the larger realization. According to a 2022 Department of Energy analysis, If scaled properly, these acid mine drainage sites could produce up to 2,200 metric tons of rare earths annually, more than the output of Mountain Pass, America's only active rare earth mine. It wasn't a mine. It was something stranger, a strategic gold rush built on mud. Turning poison into powder. Turning toxic sludge into usable rare earths required ingenuity. Scientists developed a two-step pH separation process that mimicked nature's chemistry, but under controlled conditions. First, lime was added to the acidic water, raising the pH just enough to precipitate iron and aluminum while leaving rare earths dissolved. The result? A cleaner, metal-rich solution ready for the next phase. This liquid was pumped into massive geotextile bags, giant fabric pillows where water seeped out slowly, leaving behind a thick, concentrated paste. Once dried, it was still impure but potent, a semi-solid treasure trove that held the metals needed for everything from EV motors to missile guidance systems. The final refinement came through solvent extraction, a process resembling oil separating from vinegar in a salad dressing. Specialized oil-like liquids were engineered to selectively bind rare earths. By repeatedly mixing and settling the solution, scientists could achieve 99% pure rare earth oxide powder, ready for industrial or defense use. Nature had done the hardest work for them. The rivers had dug, crushed, and dissolved the metals. The engineers only had to capture, concentrate, and refine. Across Appalachia, hundreds of sites could be tapped this way, forming a network of distributed, invisible mines without opening new pits or devastating landscapes. What had been dismissed as pollution now held the potential to transform United States industry and national security. But just as solutions emerged, the world shifted. China's tightening grip loomed, threatening to make these domestic breakthroughs all the more urgent. When exports became weapons, while American scientists were unlocking the river's hidden wealth, China was rewriting the rules of the game. In April 2025, Beijing implemented sweeping export controls on 7 critical rare earth categories, halting shipments to the United States and Europe. Factories paused, automakers scrambled, and defense contractors faced component shortages that threatened sensitive programs. The first shockwaves were economic, but the second move was strategic. China didn't just restrict metals, they banned the export of processing technology, effectively preventing anyone outside the country from learning how to refine what they produced. It was a chokehold, not just a material shortage, but an intellectual blockade. Suddenly, rare earths were no longer just inputs, they became weapons. A single policy in Beijing could stall the production of EVs, disrupt wind turbines, and even affect military readiness. Industries dependent on dysprosium, neodymium, and terbium, key elements in high-temperature magnets, had nowhere to turn. The United States realized it could no longer rely on waiting for China to allow access. Factories might run out, defense systems might lag, and the green energy transition could falter. Supply lines were fragile, and the clock was ticking. Washington needed alternatives, and fast, so the attention shifted from rivers and sludge to a global stage, where alliances and partnerships would become as critical as the metals themselves. Alliances forged in ore. As China tightened its grip, the United States moved quickly to diversify its sources. Domestic rivers could only produce so much, and time was short. Washington began forging strategic mineral partnerships with countries that had untapped rare earth deposits. Pakistan, India, Mexico, and Japan became priority allies in this quiet but high-stakes resource war. In October 2025, Pakistan delivered its first consignment of rare earth elements to the United States under a $500 million agreement, a symbolic and practical milestone. India and Mexico soon followed, coordinating supply, processing knowledge, and logistics to reduce dependency on Beijing. These alliances weren't merely trade deals. They were a global strategy to ensure that the West could access the minerals essential for technology, defense, and energy independence. The stakes were enormous. Rare earths were now a geopolitical currency, shaping alliances and dictating industrial power. Countries that had been peripheral suppliers suddenly became central players. By aligning production, transport, and refinement, Washington was creating a distributed, resilient network, capable of weathering Chinese export bans. Yet even as the deals inked on paper brought hope, the challenge remained. Could these global agreements, combined with domestic river mining, scale fast enough to meet demand? Every shipment and every bag of sludge counted in the race against time. How fast can we dig? The rivers of Appalachia flow constantly, refilling after every rain, but capturing their hidden wealth at scale is a monumental task. Pilot plants show it can be done, yet hundreds more facilities would need to operate simultaneously to meet national demand. Even with international partners supplying critical minerals, scaling production fast enough to counter China's chokehold is a race against the clock. Engineers and scientists face both technical and logistical hurdles. Each site requires careful chemical balancing, filtration, and solvent extraction to isolate high-value rare earths. Transportation, refinement, and integration into manufacturing supply chains must be synchronized with new imports from Pakistan, India, Mexico, and Japan. Any delay could cascade into shortages in EV motors, defense systems, and wind turbines. The stakes are existential. The same coal industry that powered America's rise left behind rivers of orange sludge, now transformed into a potential lifeline for technological independence. Yet, there is no margin for error. China continues to monitor and restrict the market, ready to tighten its grip further. In this silent war over minerals, every ton of sludge, every international shipment, and every operational plant represents a small victory. But victory is measured in speed, scale, and the ability to turn yesterday's pollution into tomorrow's power. The question remains, can the United States act fast enough before global reliance on China becomes irreversible? The coal-stained rivers that once powered America's rise now hold the keys to its technological future. In the silent war for rare earths, the battlefield flows quietly under bridges and through forgotten streams. Follow the journey, witness the hidden battles, and see how resources can reshape a nation.